welcome all. I'm Scott Dietzen, as was said. I'm the CEO of Pure Storage. We're certainly thrilled to have you with us today, and the online community as well. I know we're maybe a little bit different than some of the other folks that you're speaking with on this tour, but we remain convinced that the Achilles heel of virtualizing I/O-intensive workloads remains mechanical disk. And Flash is poised to be the answer for that. But up until now, Flash has carried a price tag that is prohibitive for most users. So, Pure's mission is to put Flash into a form factor and package it with the right innovative software that allows, Flash to compete on a dollars per gig usable basis with traditional disk arrays. So, this is what we're going to talk a little bit about today. In fact, here's the rough agenda. Everybody should be wired now with caffeine and sugar, but if you need to duck out, there's more available. We'll set this up very briefly. We want to spend the large majority of our time talking about the technology, talking about customer use cases, and giving you real-time demonstrations of how all of this stuff fits together. One of the things that's particularly fun about virtualization is the ROI. We have customers that have actually saved enough money on enterprise license fees with their server consolidation because the storage got so much faster that the storage ended up better than free. Those kinds of returns on investment are really easy to get customers signed up for. So we couldn't be more excited about the prospects. Let me introduce some of the folks that are going to be talking today. Actually, we'll talk about the team as well. We couldn't pull this off without a truly spectacular team of technologists, and I'm thrilled to be the corporate overhead representing such a stunning team. But we've got DNA in the company from Veritas, from NetApp, VMware, Data Domain, Google, that's really helped build the technology that you're seeing today. Representative from Pure is John Hayes. John Hayes is our founder and chief architect. He is in the handful of best minds I've had the opportunity to work with in my 15 years in the Valley. We have Matt Kixmuller, who heads up our product organization. He ran the backup business for Veritas and Symantec before joining us. And Ravi Venkat, who is our virtualization solutions architect. Ravi is from VMware, and he did the virtualization solutions architect job at Cisco before joining us. And then we have Michael Cornwell, or MC, back there. Michael was involved with the launch of Flash for compute platforms. So he was at Apple when the decision was made to move the iPod from spinning disk to Flash. He looked after the iPhone Flash architecture, and then went and was the CTO of Flash for Sun before joining us. So I think that's all of the critical people. A couple other things to mention about this team, though. We've attracted some elite and valuable investors in this quest that we're on. So we have Anil Bhusri and Frank Slootman, who led Data Domain from its founding and then through its IPO. The thing that's pertinent about Data Domain is they really challenged the HSM architectural view of the day, right? That you want to continue to use tape, or that the right solution is disk front-ending a tape library, and they use data reduction to make the case that an all-disk backup appliance made more sense than hybrids. Interestingly enough, we are trying a very similar play in primary storage, but replacing disk with Flash, of course. No disk in our box. It's also good to mention that we have Diane and Mendel, the co-founders of VMware, are angel investors in the company. In addition to talking technology with us, they've actually come in, spend time with the management team and the entire engineering team, talking about the culture of VMware and how they were able to build an elite team and keep that team on track and productive. So I think, I should also mention Samsung is yet another investor in the company. Samsung collaborates with us on getting Flash into a form factor that allows us to do our magic and bring the price point per gig usable down with that of hard drives. So I'm going to turn it over to Kix, and we'll count on you guys to help us drive and make this as productive and technical a morning as possible.
All right. So Ravi and I are going to kind of go back and forth and tag team this section, and we're going to bounce back and forth between some basic background on what we do, customer examples of successful use cases of our storage in virtualization environments, and then demos of stuff in the lab. And we'll actually end today by going in our lab and showing you a little bit about the gear as well. So just a little bit on why we're here and why we think virtualization is such an important use case. And if you look at our early adopter customers, we've deployed our technology to about 30, 35 odd customers now, and a good 65% of them are virtualized environments. And the biggest challenge in a virtualized environment is that term you probably heard before, the I/O blender. So you take what used to be a bunch of well-ordered workloads that had their own dedicated storage on the left, and there was a whole business of kind of crafting that perfect storage for each workload. And you tried as hard as you could in the old world never to mix workloads, because that's how you destroyed performance. And then enter virtualization, munge all those workloads together, and what do you have? Kind of a performance nightmare for traditional storage, where basically you generate a ton of random I/O. And even applications that before didn't used to really impact storage all that heavily, when you mix them all up and put them on the same storage pipes, you have a real issue. And so when we go out and talk to customers, what we hear over and over again now is that storage is becoming their key bottleneck. It's almost never CPU. Sometimes it's RAM, depending on how much RAM they put in, but storage is a big piece of it. And so in addition to that kind of limiter of scale where they just hit a bump in the road and can't virtualize any further, a lot of people are also in this zone of having already virtualized the easy stuff. And so maybe they've gone 50%, maybe they've gone 75%. And the extra 25% of their apps are the tier 1 apps that drive real I/O. And they're already having storage problems. And so that's kind of the next challenge. How do you solve that tier 1 app problem? So the result is what we see in a lot of environments, what we like to call storage shenanigans. And it's kind of things people do that aren't perfect to make up for disk being the limiter in their environment. And I'm curious as to what kind of shenanigans you guys have seen out there in your environments, and if any of these ring true. But things we see are a lot of retrofitting of the old model in the virtual model, where even though it's a big virtualized environment, they'll have a little island for one app and a little island for another app with dedicated storage, just because they want to maintain that performance. They'll do things like use way too much DRAM, because basically they need the I/O, and the hit to go back down to disk is too far. They'll have things like dedicated RDM LUNs. They'll use tons of little LUNs. One of the biggest challenges we talk to people and why they don't particularly like fiber channel behind virtualization sometimes is that the existing model really requires data stores that are fairly small with a bunch of little LUNs behind them to get the performance you need. And then finally, one of the bigger challenges is just keeping servers around for tier 1 apps, because you can't convince that DBA to go virtual, because he won't give up his dedicated infrastructure. So what are some examples you guys see just from your careers where storage has gotten in the way? Anything you want to share with the team?
Yeah, I would definitely say virtual machines with 100+ gigs of RAM because the disk is slow. So they just offload the DB into memory.
Yep.
Popular.
Others?
I've seen all 4 of those in my time.
Isn't this kind of the normal then, not the shenanigans?
That's our view. The normal is shenanigans. So what's our goal? And ultimately what we want to be held to is, at the end of today, does it feel like we made progress on this? And so our goal is to really use Flash to enable virtualization to the fullest. And when we think about virtualization to the fullest, what that means is get to 100% virtualized, make sure all the apps can go on the virtual platform, run a fully shared infrastructure where you don't end up taking your virtual infrastructure and dividing it up. Make the virtual platform actually better. One of the biggest challenges I see when I talk to VM admins is they just can't convince that 1 or 2 DBAs to give up their dedicated infrastructure. And one of the interesting things we found with a number of our customers is that when they convinced the folks to move over, when they moved over to virtualization on Flash, the end application experience was actually better. And we'll share some of those. And so I think one of the key things is not going to the DBA and saying, don't worry, it'll be good enough. It'll be almost as good as your existing. You won't have any issues. It'll be, look, you want to move because this is going to be an upgrade for you.
Actually, I see this as a stopgap, to be honest.
Which part?
Flash storage in general. Because, I mean, if right now it's fixing a problem, yes. But if I actually had applications that were designed for the virtual and cloud environments, this goes away. Because you need to start thinking about redesigning the application. Instead of thinking about just taking Oracle and shoving it onto the virtual environment. Take what Oracle is doing and redesign the app to do the right thing.
But what if you can't?
You have to.
Yeah, but there's too much to move there. You
Well,
can't
there's a lot
get
of
people to fix
history
the apps.
there, and that's the problem with
Too much
almost all
in that.
compute environments. But if you really want to go successfully to the cloud,
Well,
and
and
actually
Even
have
if you
cloud-based
go
apps.
to a DAS deployment model, right? Virtualization still requires, it has a more intense random I/O stream, and so you put disks into the local server you still hit these same issues, right? So it turns out that flash is arguably the answer. And one of the things that's compelling is that the economics for flash actually run in reverse of those for disk. It's cheaper to put flash in shared storage than it is to insert flash into the server tool.
I think flash is a valid, very valid solution to a current problem. I don't know if it will be the solution when we start having truly distributed applications out in the cloud, because the cloud application model is hugely different than what we have today.
And yet the chief proponents of it, Google and Facebook, Apple, Salesforce, are all deploying flash in their cloud architecture.
Yes, but they're not actually, I arguably may not actually have 100% true cloud-based apps.
Yep.
They present a cloud or software as a service, but their back end is still pretty risky.
Yep, and I think we generally agree, and if you look at who we generally sell to, it's more typical enterprises that can't make the leap to cloud on day one. And we see two levels of re-architecture. We see a bunch of apps re-architecting for the new model around cloud deployment. We also see Flash changing how people re-architect their apps. And if you look at our typical customer experiences, they'll move to Flash, they'll get an enormous boost right away in terms of performance, but then they'll realize that a bunch of the way they architect their application is actually wrong because their app immediately becomes the bottleneck. And so it's an evolution with all these new technologies. The new model for Flash, the new model for the cloud.
Is your plan to replace all disk, or still have a tiered approach?
We'll get into that, but the short answer is if it's a performance disk, and if it's an app you care about, if it's a workload where performance matters, we think it should run on 100% Flash. And we can do that economically for under the cost of disk. All right, final thing here is just contributing to the ROI. One of the things that we see in a lot of environments as well is that people have these goals around virtualization to save money, to save power, to consolidate servers, and then they end up having to turn around and give that money to their storage vendor because they need bigger, beefier storage to keep up. And so our vision for storage in a virtual environment is it should actually contribute to the ROI of virtualization. It should be more power efficient, it should be smaller, it should be easier to run, it should move the ball forward as opposed to hindering virtualization. And that just goes right into simplicity. And the final thing that we hope to leave you with after today is a kind of one of those wow moments of I never knew storage could be so easy. All right, so to get to Dwayne's question a little bit, we like a quote that just came out of an analyst report from Forrester, where our friends there said basically, look, if cost were no object, wouldn't you just put all your data on Flash? Wouldn't that be nice? And as we go out and talk to customers, their general experience with Flash is great. They've used Apple products for years, they put it in their laptops, they're having good results. They've used it on maybe a couple environments in their data center, but then they hit this wall, which says, uh-oh, I can't. It's this great technology, it's 30 times faster, 10x smaller, 10x less power, but it's 5 to 10x more expensive. And so the cost wall just slams right into them, and they say, okay, let's just self-select for a few of the environments where cost doesn't matter. So if you look at how the storage industry has kind of reacted to Flash, there's basically been two approaches that have come out. The first is to basically use the race car tier 0 approach, as we call it, where essentially you just use a little bit of Flash for your most important applications. Small databases, and the areas where you can maybe use a host-based PCI flash card, put it all in the flash card and go off to the races. And then maintain a tier 1 and a tier 2. A lot of the industry is focused on this model, because if you think about a traditional disk drive vendor, they don't particularly want to go out and sacrifice their very, very rich tier 1 disk revenue stream. They would love for Flash to be thought of as this new race car that sits across the top that demands a price premium. And so a lot of that's just kind of the mindset of the industry as well. The other approach that you see people doing is essentially mixing Flash and disk, where you take a little bit of Flash, usually around 5%, and a lot of disk, around 95%, and try to get good at moving the hot IOs to Flash and the cold IOs to disk. And our view here is that the picture says it all. It's a bit like taking a rocket on a turtle, where you have this 20x difference in performance. And the key downside here is unpredictability. On an IO for IO basis,
Fun to watch.
It is fun to watch. We have a demo later. No. The key downside here is unpredictability, where you just don't know what's going to happen when you light that rocket. Every IO for IO, you don't know if you're going to hit disk or Flash, and you basically can't redesign your apps. You have to design your apps to expect disk, and when you happen to get a Flash IO, you get a great response, but you can't redesign for Flash. So our view, pretty simply, is that every app should run on Flash. That doesn't mean every spinning disk in your data center is going to go away. There's still use cases for backup, for archiving, for big content farms, for things where performance doesn't matter. But if you have an app where response time and performance matters even a little bit, and you would have bought up over low-end SATA drives, our view is we can make it economic to run your apps on flash, and especially the virtualized ones, given the I/O contention challenges for virtualization. So why all flash? If you look at most of our competitors, they're very much singing the tiering story, because that's their religion. Their religion is get disk and fix it. And so our view is pretty well encapsulated in this chart, where this is kind of a latency histogram of a given application, and it compares 4 different workloads, or 4 different deployment models. The top one is a fully 100% disk array. That happens to just be an SPC1 result for the highest end Hitachi array, came out a couple months ago. And what you see here is very typical of a disk array, where you'll have kind of a 2-hump bimodal distribution, where you'll have a set of IOs that basically end up hitting the array DRAM cache, so they'll get serviced in under a millisecond. And you have a bunch of other IOs that hit disk, and they get serviced in the 5, 10, 15, greater than 30 millisecond range. And so your average ends up being somewhere in the 8, 10 millisecond-ish range. Now a lot of the arrays, almost all the vendors, are pushing the idea of a flash cache in your array. And that allows you to take that DRAM cache from under 1% of total storage to up around 5%. And so what does that do? That takes some of these IOs and moves them up to that kind of high performance range. Totally depends on how cacheable your app is. And so if you get a great cache hit ratio, more of them will move up. If you don't, more of them will stay back. But a big chunk of them will stay back here. Might be 50%, might be 20%, even if it's 10%. It turns out that these IOs have the biggest impact on your application. And so think about a database that's running on this storage. You have a database doing a transaction. He might issue 10 IOs for every database transaction. If 1 or 2 of them hit the disk zone, that whole transaction is waiting for disk. A new model that, yep, please.
Just to interrupt, I don't want to stop your flow.
Yeah.
I mean, if you compare what you do with a conventional disk spindle, you're always going to come across as being better. Mm-hmm. That's a given. So it's a very favourable comparison for you guys.
Yep.
And I'm noticing here it says first all flash enterprise storage array, but is that true? I mean, Astute, Whiptail, aren't they fully flash? So I mean, it's for me. It's not so much would I choose you against a conventional array which has SSD or some sort of flash to reduce the IOPS. It's why would I pick or look at Pure Storage? Why wouldn't I look at somebody else who's got all flash or all solid state throughout?
Absolutely. So there's been all flash appliances in the market for many years. 15 years. Texas Memory Systems.
True, is it?
Well, hold on. So Texas Memory Systems was the first vendor eons ago, and they've evolved over time. If you look at those appliances, though, we wouldn't call those enterprise arrays. They've basically been 2 or 3 devices where you can get 5 or 10 terabytes of flash networked up to a few servers.
Okay.
And if you then put that appliance in front of somebody who runs storage every day, they're going to say, look, this looks nothing like the array I'm used to. It doesn't have the software functionality, doesn't have the high availability, doesn't have the multi-protocol support, et cetera, et cetera. And now those have been getting better and better over time, but they just don't feel like normal storage arrays. And most importantly, from a price perspective, they haven't looked anything like a normal storage array. Normal storage costs on the order of $3 to $5 a gig HA for performance storage. These devices have been $30, $50, sometimes even $100 a gig. And so when we started, we said, we want to build something that looks like a normal storage array from a feature perspective and from a price perspective, so it can be an absolute equivalency to a traditional mid-range storage device. We just want to build it out of all flash. And so in a lot of ways, we think our primary competition is a traditional storage array. And our main value prop is going in and saying, look, for less than the price of what you're going to pay for this, we'll give you this, where we can take all your I/O and bring it up to the flash zone and completely remove all this outlier latency.
I mean, I can understand that your main competition is the incumbent, and the incumbent is traditional spinning disk. But from my perspective, that's an apples to oranges comparison. What I'm more likely to do is an oranges to oranges comparison. If I accept that flash is the way to go, I don't even look at spinning disk with cache in the front. I start comparing like for like. So I guess if I let you carry on, you'll tell me what those enterprise features are and how that makes.
Absolutely, and we love that approach. We'd love to convince people to go buy oranges instead of apples. And in fact, if you look at a recent report that came out from Gartner, they're predicting that market for just the all-flash arrays is going to be $4 billion by 2015. And so that'll mean by in that time, actually 10% of all storage sold in the enterprise is 100% fully flash. And that's not even the caching mode. So I think a lot of other people like oranges too. All right. So
the example you just used about a DB calls and all that, I'm a developer as well as a number of different things. And for example, we just did with a customer, they were having massive database problems, they were having massive storage problems, they were idling at the state. All we did was change the database and sped up everything up about 1,000 times. We changed how we were using it. You know, why in the world would I go off and spend millions of dollars on SSD when I can just fix my app to do the right thing and get the same benefit? The same immediate benefit. Now, granted, there may be a long-term benefit, but you know, if I can't force my developers to do the right thing, I'm going to be throwing good money after bad just to fix a problem that's easy to fix.
Absolutely. If you've got a problem that's easy to fix, the simplest thing you can do is change your application logic. You know, where we tend to intersect people is when their array is going off lease and they're making that next storage purchase and they're saying, look, I can buy this outdated spindle-based array for X, and I can get an all-flash array for Y, and it can have an enormous impact. And if you look at our, customers,
all it does is tell developers that you can load the code even more.
Yeah.
With respect, though,
you have to do both.
You've made that point already, so you're making the same point twice. So.
Yeah.
So.
And once you fix the app, there's still apps that don't want to wait for mechanical storage, right? They want something that performs, right? So that disk latency is significant for a class of applications, especially virtualized ones. You know, we see this over and over again where people can't get everything they want out of their virtualized deployment because the storage can't keep up.
And if you look at our early deployments, it's probably about 50-50, where 50% of them are a very point app. They've got some database that's fallen over, disk just can't solve it, they haven't been able to tune it, they need something faster. The other 50% are much more just general purpose consolidation plays where they need better storage for the consolidated environment. It's not one app to go to, and it's just everything. And so, you know, just different use cases, right? So.
And the investments they're made currently, they're not going to rewrite the code, right? So people are looking at virtualizing an existing app which is business critical to in a virtualized environment. The first thing they're going to hit is, okay, I got to get this expensive array to make it work because it's all about IOPS. So you're looking at spindle drives and you're doing the calculations, it's all about IOPS. So when IOPS come into play and latencies are high, they're not going to virtualize that app. It's going to sit in that physical server and it's going to not get virtualized. That's something we keep hearing.
I think the argument that Edward's making, you could apply to virtualization. All we've done is ported our problems away from the hardware to a virtual machine. But that didn't make virtualization a bad thing to do or as a stupid technology. It was a band-aid to fit over an open wound, but a band-aid is better than an open sore that just keeps on bleeding.
That was a band-aid over the OS that does things badly. I mean, Windows is not the most
efficient OS.
So it has something to do with the OS, and that's what virtualization helped us fix that problem. Now we're talking about going from operating system efficiencies to application efficiencies. So if we're still using the same old apps that rely on the same old operating system, we still have the same problem.
I agree with you, but we could wait for 10 or 15 years for the app to be fixed.
There you go. You can either fix 3 million apps or we can do this. I mean,
we've got a little bit of beer in the fridge, so after this session we can actually continue that conversation.
It's an offline discussion.
All right. So just to kind of close out the why you compare apples to oranges, you know, this is why. If you look at a traditional array, you end up paying $5 to $10 a gig for the spinning disk part, and you pay a heck of a lot more for the RAM part. And what a lot of people end up having to do is load up the DRAM in their arrays at enormous cost to get performance. Flash allows you to basically do that a little cheaper. Instead of spending $100 plus per gig on your DRAM, you spend 30-ish plus bucks per gig on your flash in that array. And so you can get to about 5%. You put host-based PCI cards in front of that array, you add $20 per gig per server as well. Our view is if you got a little bit of money to spend on flash, by far the most economic way to do it is to deploy an all-flash array that comes in at the price points we do. Allows you to dramatically impact performance across your environment and replace this tier completely. All right, so just to kind of wrap up, and then we'll kind of transition a little bit more into the virtualization tech. You know, what we're doing is redesigning an array from the ground up for flash. I think we talked about that pretty well. You know, fundamentally, no caching, no tiering, no disk, 100% flash. And every algorithm in the array designed from scratch for the uniqueness of flash memory. If we have time at the end, we're going to go into a good whiteboard session on exactly how the array works, if you guys are interested in that. So we'll talk about why those algorithms are different, why flash is different, how the thing was designed. And our real goal is to fix the economics. And so we fix the economics in two ways. We use commodity-grade MLC flash memory, and we do a lot of work in our software to make that reliable from a performance and an availability perspective. And then we do inline data reduction, inline dedupe, inline compression. We'll essentially use as much CPU power in our array as possible to reduce data to get more data on the same amount of flash, lowering the cost. All right, and so the interesting thing I've found as we've done this over the last couple of years is if you look at our early adopter customer experiences, the thing we hear back more and more is that I thought I was buying a performance array, but it turns out this thing is just better storage, and it's just better in every dimension. So 10x faster, 10x smaller, 10x less power, and just a hell of a lot easier to use, because it turns out one of the biggest challenges for VM admins, storage admins, everybody is performance management. And so we'll get into that as we go along as well. All right, so let's talk a little bit about VMware integration to show you guys where we're at. I used a patented example here of the Foskett VMware integration scale from a blog Stephen did a couple days ago. And so he listed the various stages of vendor integration with VMware, going from because I say it is, to on the VMware HCL, to having to plug in, to doing VAI. And so we're at a phase right now, and we'll go through our full roadmap later, but we're basically in advanced beta. And so we're kind of getting close to the GA of our product in Q2. And so basically, we have a lot of things working, but not everything is fully certified yet. And so we're very much right now in the because I say it is good enough camp, where we've got probably 20 at least of our 35-ish installs in virtualized environments, both vSphere 4.1 and 5, VAI running, et cetera. But we're not on the HCL yet. We'll be on the HCL when we come out with GA. And will be largely fully compliant with VAA at that time. So right now we essentially have all the VAI primitives working except for the extended copy one. And so that one hopefully be by mid-ish year.
I see something missing in Stephen's scale,
okay.
Which is support for VMware's Site Recovery Manager, having a site recovery adapter and being able to do replication between the arrays.
Absolutely.
Is that something that's in your roadmap as well?
Yep, so our first gen product does not have replication. And so right now what we do is we partner with third-party replication firms and allow app-based replication. But we will be shipping replication, and when we do ship replication, SRM plugins an obvious thing to do.
Okay.
So.
Do you know whereabouts that is?
Why don't you hold roadmap questions until the end, and I'll just go through the entire roadmap a little bit more logically.
Sure.
And then the other thing here, obviously, is a vCenter plugin. It turns out one of the reasons vCenter plugins exist is because storage is really hard to manage. And so when we go to look at building our vCenter plugin, which we're doing, there's a hell of a lot less for us to put in there. But we are going to do a vCenter plugin, and that'll be sometime in the second half as well. All right, so a little bit of an update on where we are in terms of deployments. So as I mentioned before, we've got over 35 deployments of the technology to date. And basically, if you look at kind of the industry and application mix, there's a couple of interesting things to pull out. One of the analysts said to me when we reviewed this with them, hey, it's refreshing to see a flash company that has customers that are outside of spook government agencies and Wall Street. And one of the great things about our product, and in terms of how we position and appeal, is that we're a very broad use case. We've got firms that range from manufacturing clients in the Midwest on through to the biggest internet companies in the Bay Area and the biggest guys on Wall Street and everything in between. And so there's been a very broad cross-section of use cases. In terms of applications, what we listed here was the primary app. But what this doesn't show is that most of the SQL and Oracle, or a big chunk of that, is also virtualized. And so I like to tell people that about 50–60% of our environments are virtualized, and 50 or 60% of our environments are databases, and the overlap is virtual databases. And so you can kind of see the example there. But the key use cases are obviously VMs and databases. And then we have a set of other technologies as well. And so we've talked a lot about data reduction. Our arrays call home every night. We get all the information on what people have been doing, how their performance has gone, what dedupe levels they're getting. And so if you average data reduction over all these deployments, in the virtualization space, the average data reduction is about 8-to-1. And that has a wide range of people who are higher. We have some people that are in the 10 to 15 plus range. Those guys tend to be people that use a lot of eager zero thick VMs, and so there's a lot of zeros we can take out. For people that are thin provisioned and don't write as many zeros to their array, they tend to be more in the 5 to 10 range, but very reliably in that zone. And then if you look at the average database level reduction, databases do a little less well with dedupe, do a little better with compression, but we still get surprisingly high dedupe rates from them as well, or at least surprises a lot of people. And people in that range tend to be around 5-to-1. anywhere between 3 and 8 is typical.
That's across the board for all data structures.
Yep, across the board. I mean, this basically we just look we look at the average for the entire array and what they've achieved. All right, so enough from the marketing slides. We're going to dive in and do some hands-on stuff now, show you some demos, talk a little bit more about some of our deployments. And what we want to go through here is kind of just a chain of arguments around why virtualization is improved by Flash. And so the key 5 things we see are basically helping you improve scale and consolidation, getting more VMs per server, helping you improve your application performance, allowing virtualized apps to actually work better than physical, simplifying the VM provisioning process, making it real easy, taking all the storage choices out of the way, streamlining operations. You know, one of the best pieces of feedback we get from people is just this amazement on, wow, I can actually provision a VM in that much time, and things like that. And so at the end of the day, if you can take a bunch of admin tasks and reduce all of them by 10x, that's a huge savings for somebody. And then finally, VDI. And VDI is an area where the ROI for VDI is tenuous at best. And so the storage is often the thing that kind of kills it. And we want to talk about how virtualization can help that. All right, so the first thing to show scale that we like to show people is actually a demo we did at VMworld last year, if you stopped by our booth or happened to see us. And at this time, if you rewind almost a year now, vSphere 5 had just come out with its new 64 terabyte data store and other features. And so we wanted to show folks what an environment could look like in hyper-consolidation. And so we basically went and got 2 hunkin' big servers, created 2 enormous 64 terabyte data stores that were all thin provisioned, put 1,000 VMs with various workloads in there, and ran them all. In this test, we got 20-to-1 data reduction, over 100,000 IOPS, and consistent sub-millisecond latency. And Robbie will explain a little bit more about what we showed and what we did.
Thank you. So these 2 big servers were from HP. We loaded up with almost 2 terabytes of RAM. And we also had 2 big 64 terabyte long provision from Pure Array Box. And the beauty part was, we started all these VMs, and then, as you can see the bottom portion there, each of these LUNs were taking almost 50K IOPS. So 2 of those LUNs were doing 100K or more IOPS. And the fun part is the millisecond latency. You see it's showing 0 because the millisecond range, we are way below millisecond range, and you can see the average is like 0.006, it's like 6.
Turns out VMware never thought anybody would have under a millisecond latency, so they round to the nearest millisecond.
So the flat line to 0 is sort of, everybody came like, are you sure you're doing something there? And then we show the I/O ops, and like, I want to see the VM which is doing the I/O. So we show them the VM which is doing the I/O, and like, wow, they were like really surprised to see that. So that's sort of the scale we wanted to demonstrate, and also say that, the LUN decision about should I provision a big LUN or a small LUN, or should I do RAID or RAID 0 or RAID 10 or whatever, all that is taken away. You just create one big LUN, give it to the vServer admin, vCenter admin, and that's it. You don't have to worry about whether you have to increase a LUN or decrease a LUN. So that's one advantage of it. Other one is obviously the IOPS and latency.
So do you recommend, if you buy one of your arrays, you just create one massive data store, which is the entire capacity of the array?
Well, we also a thin provisioned array, and you could create either, like you can do the traditional way of creating a bunch of smaller LUNs, or you can create these big LUNs and never go back and do any resizing activity, or worry about, okay, it's running out of space, I got to set this alarm. So it's entirely up to you, but we found there's no difference in actually from a performance perspective, or
Because there are some storage firms that have taken exactly that approach. Tintry, you have an array, it is one data store, there are no LUNs, RAID levels, any of that.
Yep.
Which I think is an interesting approach.
Let me go a step further. So, kind of between Ed and Mike here, a lot of times you'll have an application that's a Tier 1 application that'll require latencies. How do you, in your system, say this can never exceed 2 milliseconds? I need to guarantee this application with a certain performance. When I start doing things like backups over the top of that, and I start doing, my entire environment right into this, how do you guarantee a certain application or a certain data store has priority over everything else? Or
to Ed's point, if you've got a huge database, how do you prevent it from taking over the rest of the array?
In fact, how do you make your array application aware?
Say it again.
How do you make the array application aware so that I have this multi-tier application with a web front end and database, middleware, and 17 other different layers?
So I can interject. Our focus on the first version of the product is really about making the pie bigger so that those other problems go away. And we do internal queuing based on like the sizes and the source of I/O to keep them separate, but it's very coarse. We built this for an enterprise environment that is relatively controlled, but something like the idea that an application would actually outcompete everything else would require a great deal of effort to tune the application to even make that possible. So, like, customers rarely manage to exploit all of the performance that the array has to offer.
And one of the things that's different about flash storage compared to disk storage is that two workloads actually don't compete with one another. You think about basically a spindle. That spindle, and you even want to say, I want to give 10% of its IOPS to one app and 90 to the other. If the 10% IOPS causes a spindle to turn, it impacts the 90%. Flash basically has a bucket of IOPS, and none of them compete with one another in a lot of ways. And so what we've found in our general customer environment is that no one's been able to even push the array to the extent that it can perform. We have designed quotas and things like that, and kind of I/O caps and fencing in our architecture. We just haven't implemented it yet because we haven't had the actual need for somebody to come to us and say, wow, I've actually hit that situation. And then finally, I'd say, probably the place we believe this should be done the most anyway is VMware. If you look at what VMware is doing with storage I/O control, it's early, it's a first generation. It was certainly designed for disk. Its smallest increment is 5 milliseconds, and so it wouldn't help you in that case. But we're trying to give feedback to VMware on how they can redesign storage I/O control and some of these things to be kind of pertinent to the flash era. Right. And ultimately, we think you should define those things at the VM level. And we'll just see if that becomes good enough, great. If we end up having to understand that, inherit those policies, and enforce them on the array, we'll do that over time.
I mean, how many, when you have like each shelf of this, is this many IOs? I mean, how does a person know how to size this to your environment?
So basically the whole array has a big bucket of IOs. There's no proclivity per port, per shelf. They can go out any port. There's just, a lot of the things you had to do in an old array where you counted spindles and configured LUNs and had dedicated cache and put them out the dedicated port, and a lot of that stuff just doesn't make sense in our array. Yeah. And you'll understand why as we get into the architecture and we show you how it works on the back end.
But you end up effectively gated on CPU, right? So there's a number, with a given CPU configuration, you can drive a specific amount of IOPS against these, the collected back-end SSDs. You scale IOPS by adding controllers. You scale capacity by adding shelves. And the thing that makes it so easy, is the latency just looks flatline across the entire operating range of the array, right? So the customers really haven't pressed us at all on SLAs because as long as they're within the parameters, they just see this flatline latency. So there's no spindle contention, right? So you don't see the hockey stick as the workload cranks up on the system.
How are you measuring this latency? Is it just inside VCOps, or do you do per microsecond?
So you're talking about how we measure it inside the array?
How you measure it inside the array, and how can you display that to? I don't want vCenter rollups because it's every 5 minutes. This all the peaks and valleys. I want the peaks and valleys. I want to know without a shadow of a doubt that microsecond had a spike, so I can track it back to the application and find out what in the world happened.
We'll show you the GUI in just a couple minutes.
So to kind of summarize, all volumes are equal for us. So unfortunately, we can't use the SIOC with vSphere 5.0 because the minimum range is 5 milliseconds. And if there is a 5 millisecond latency, I think there will be a support call to us.
There's no effect with SCSI locking at all, like having one data store with. Is it?
We have ATS support, so it's fine.
So we have the VAI ATS API is implemented, so we have that support. I think that's all I can talk about this.
One more, actually.
We actually also had the VDI demo, which had similar 1000 Windows 7 desktop deployed, and it was running ViewPlanner. And the VMs were looking as though they were like running on better than running on your laptop. So that was one of our other demos. See, this was our old GUI, so the new GUI has drastically changed. So one of the important things is, as you see here, is the deduplication. So we had deployed almost 6 terabyte of storage to the ESX server, but it was stored on the back end as like almost 417 gig. It's almost 6-to-1 reduction ratio. So that's one thing. And of course, we are showing dry pull tests where we can pull a drive, and the dry pull was really happening faster. So that's the status of the drives there. And we are seeing anyway from bandwidth anyway from 250, 300 megabits per second to almost 1 gigabyte per second. So the average latency was around half a millisecond or 500 microseconds. So this was one array with 600 KIOPS. Another array was another 600 KIOPS, which had the 64 terabyte one. Any questions around dedupe, compression, and?
Can you shut off the dedupe?
No, it's on by default. You can't turn off.
Do you know what that hit would be if you could? Like, you're a flash array, so you're kind of like you're fixing a performance problem. So if I wanted more IOPS, why not have that?
So when we get into the architecture, you'll see why. But the way our array works is just totally integrated with how the dedupe works. And so at the end of the day, our goal was not to be the fastest array in the world. We'll let other people build basically the $100 a gig storage to go to the moon and back. Our goal was to be 10x faster than traditional storage platforms at the same cost. And so that's the core.
So dedupe in our array typically improves performance. It doesn't degrade it. Because when you take a consumer flash drive and you go through the entire cycle of writing and flushing and waiting for it to settle and carefully managing the performance, you actually don't have a lot of bandwidth to write out to those SSDs. Now, the user writes are all buffered in NVRAM, so you don't see the cost of dedupe. There is latency introduced, but that latency is between when we acknowledge the write, when it's already cloned onto NVRAM, and when we write to SSD. So by reducing the data before we write to SSD, we actually improve the overall bandwidth of the array.
That being said, if you've got an application that supports inline dedupe itself, is that something that you would have them turn off? I mean, what happens if Veeam or Symantec writes dedupe data to an array that's dedupe?
We'll see. That's just down to testing. We actually did a demo up at Oracle World this last year where we had 2 databases, one with Oracle compression turned on and one turned off with the exact same database. And we outperformed the Oracle compression by, I think, over 5x. And they both compressed to the same thing on our storage array, plus or minus, I think, 3%. And so our general view is that all forms of dedupe compression take CPU cycles away from your host. And so if our array can do it more efficiently, let us do it. But if there's some compelling reason to do it at the application tier, go for it. It won't hurt us.
And our granularity is very, very small, so we catch a lot of blocks compared to any other reduplication software.
Yeah. If you look at most host-based dedupe or compression technologies, they're really geared to be pretty good, but not as thorough as they could be because they have to trade off performance with, kind of thoroughness. And so we're able to have a much higher optimization around good dedupe. So
I'm going to give you some grief on that 30-to-5 server.
Yeah.
I'm not seeing how the storage affects the amount of memory needed for your VMs, basically.
Yeah. So let's talk about this one real quick. Okay. So one of our initial customers is Siemens and their e-meter division. Brian, who's the owner here, was actually going to be here today, but he had to take a business trip at the last minute. But they've been a great reference for us in terms of what they've been able to do. And they have an interesting application in that it's a multi-tiered app where every e-meter instance, what they do is they do smart grid power management for electricity providers. So basically, they go and sell to all kinds of end-user electricity providers. And an instance of their application is actually 5 separate VMs. In the past, it was actually 4 VMs plus 1 physical Oracle instance. And they basically were not able to virtualize the Oracle instance because it just had a performance issue where they couldn't bring it into the virtualization sphere. And they weren't able to really virtualize the disparate customers together because of performance issues between the VMs. And so if you think about their lives in development, what they would end up having to do is every time they did a POC, every time they wanted to test a version, every time they had a support call and they had to bring up exactly the right version of a customer's environment, they would have to spawn off a new complete stack, go get 2 physical servers and get it up and running. And so they basically transitioned to a completely virtualized lab where they took 15 of their instances, put them on 5 boxes, and basically got 6.7 to 1 data reduction. As we were talking about earlier around Oracle, they actually saw their Oracle performance increase, so they were worried about virtualizing it. When they virtualized it, the Oracle performance increased. And then they use a lot of snapshots because it's kind of a test dev environment, and he found operationally his snapshot release time was dramatically faster. And so, RAM basically wasn't their problem, essentially.
All right, just wanted to clear it up.
Yep. So
when you talk about integrations, I mean, we were talking about VAI or VASA, or do you guys have a VASA provider?
Nope, not yet. So back to this slide real quick. So basically what we focused on right now is VAI. Our next goal will be essentially SRM once we have replication and a vCenter plugin. And we're looking at VASA, just on the list. Haven't done it yet. All right.
So for now, since you guys don't have VASA, we have to build our storage profile specifically around your array. Can I get that same information from the array somehow, so I can build that profile by hand? Because if I'm going to do storage profiles and I have pure storage for SSD, I may have disk spindles for something else, and I still want to do my tiering, and I want storage DRS to do the right thing.
You can build the profiles. Based on your application, we can give the ballpark range. But given the storage profile defined by SIOC, it's kind of all storage DRS also has a minimum of 5 milliseconds. So you have to put that bar to the 5 millisecond range and build this golden profile and apply it and put all the pure ones over there. I've done that in the lab.
So you guys provide that information somehow already? Do you have it on your website? I can go and say this is the best way to set the storage profile, or is it just some blank match that?
No, but that's a good idea. We'll take that on, and Robbie's been doing a set of detailed blog posts on these things. So why don't we take that one on a upcoming blog post?
I'm curious how many people here are even using the VASA integration or with their clients. I mean, I've seen it once.
I'm using it in my lab. But
yeah, I mean,
just
lab, so not a huge deal.
Okay, while we're still on the topic of improving just application performance, Robbie's done a lot of testing with Exchange and JetStress. And so we've done a bunch of testing in our lab, and we were getting pretty good results. And so we decided to go out and look in the vendor community around what a traditional storage array does. And our friends at EMC just recently published some results they were proud of for the VNX. And we just thought it wasn't exactly the same configuration, but it's pretty darn close. So they're interesting from an A to B compare perspective. And so if you look at the EMC VNX benchmark, they did 20,000 users at 0.15 IOPS per user, so a load of 3,000 IOPS. So we basically did 3,000 users at 1 IOP each, so also a load of 3,000 IOPS. Theirs was on 5 VMs, ours was on 1. Theirs was on about 80 SAS disks in the VNX, and ours was on just 1 shelf of Pure. And so I'll put the thing on the left there just to prove that those are the real EMC results, even though you can't read it. But the key things are summarized here, where basically the IOPS, the target IOPS for both tests was 3,000. We realized a little over in both cases. They were delivering dB average read latency of 14 milliseconds. We were delivering 1.38 milliseconds. And so if you just look at that 10x difference in terms of response time every time somebody does something in Exchange, the end user experience is going to be dramatically improved. And then we also had improvements on write latency and log rates as well. And if you look at the cost of those two configurations, they're about a wash.
Have you done power comparisons as well?
We have done a lot of power comparisons on our array, and we're somewhere in the range of 5 to 10x reduction in typical power. But we didn't do it as part of this specific test.
It'll be huge.
Yeah.
Yeah.
Because all these two controllers and 2 shelves, it only consumes less than 10 amps. It's just unbelievable.
Yeah. So if you look on our website, you can get power specs and see the difference there.
Do you have a density too, like how much, like a space density in the rack, like how that compares?
Yeah, so our base configuration is 2 controllers and 2 shelves, and that's 11 terabytes raw, and it's about 40 to 50 terabytes usable depending on your dedupe. And so in a traditional array, 40 to 50 terabytes is the better part of a full rack. All right.
I don't know if I'd agree with that
No?
necessarily, but not a 2-inch extract.
Okay, well, it depends on your disk type, your performance, what kind of RAID geometry, but when we're comparing against, performant disks, people usually have a couple 100 gig disks, etc. So. All right, one other performance example. A customer of ours in New York is a high-end, basically a web advertising company, one of the leaders in the space. and they do a ton of analytics. The whole web advertising space is all about analytics. And so they happen to have a Postgres database where their production environment essentially runs in RAM. So they've got a bunch of servers, a bunch of RAM, and they run live, because that's the live kind of clickstream kind of data. Every night, they dump that over to an analytics environment. And that analytics environment's fully virtualized. Their old environment was essentially completely DAS fiber channel disk. Every one of their servers, I think, had 48 DAS drives. And basically, they would dump that data over every night, and it would take them a full 12 hours to restore and re-index it. And so they were just not even able to do analytics at this point. And of course, they're growing like a weed. And so they moved to Pure Storage. They're able to get that down to just over 2 hours. They took a bump in the road to us and tried out a famous maker array and found that it didn't really improve over their DAS much at all. And so if you look at what they're trying to do, really the random analytics nature and the fast kind of reindex time was key for them. All right, so now we're going to get a little more interactive and some more examples around simplifying VM provisioning. So one of the key things that we want to kind of prove over the next couple minutes is just how much easier it is to run storage in this environment. And I think our general goal here is to just have people to stop thinking about storage. Most VM admins I meet don't want to have anything the hell to do with storage. And they're sucked into it kicking and screaming because it's just a big pain and it's a big thing that they have to understand for their growth. And so if you look at the differences in our model, the first one that we brought up earlier a little bit, that Mike brought up, is all around kind of supersizing the storage objects. One of the things that makes NFS a little nicer than Fibre Channel in a lot of environments is in NFS you can create one big pool and put everything in it. Whereas in the Fibre Channel world, people often have lots of little LUNs, lots of little VMs, moving between data stores, etc. I'm sorry, lots of little LUNs, lots of little data stores. And so in our array, our general advice to people is just create one big LUN and create one big data store. There's no performance difference. You can have 10 LUNs or one LUN on our array, they'll all perform the same. And so operationally, that just makes people's lives a ton easier. The second thing, and we'll show you some data around this, is VM alignment. And one of the key issues that we keep running into with customers is just alignment with their storage arrays. 5 years later, as when this first came up, even with all the tools out there to automate alignment, et cetera, it's still a major issue. Our array virtualizes down to the 512 byte geometry. So what that ends up meaning is you can pick any alignment you want at the upper tiers of the application in the VM, and it'll all have the same performance on us. And we've done a bunch of testing to prove that, and we'll go through that in just a minute.
So you say you right size the disk geometry prior to the OS actually putting it?
We're saying basically, everything in our array is a multiple of 512 bytes. So you can pick any geometry you want up at the higher levels, and you'll hit an alignment of a block for us. So an I/O will never cause more block reads from our device than it absolutely needs to. Thick and thin. There's been a big discussion over time around, is there performance differences? VMware came out with a big paper that said, no, they're all the same. We wanted to see if that changed at all with Flash. And so we did a bunch of testing on the different types of VMs. Turns out, they all perform the same on us. They all reduce down to the same size, so it doesn't matter. You can let us remove the zeros or VMware remove the zeros. And because of our VAI integration with Write Same, even eager zeroed thicks are very, very fast to create. And so we'll show you a couple of those. And so,
are any of your customers deploying VDI on it today?
Yep, actually I have a case study on VDI, I think a few slides coming up.
Okay, I'll hold my question
All right,
until then.
cool. And so at the end of the day, what we want to kind of tell people here is basically just stop thinking about it. Create a big data store. Don't worry about IOP calculations or RAID or performance valuing, workload isolation. None of that matters anymore. So one of the global electronics vendor whose devices I'm sure many of you know and love or are fanatical about came to us with a lab problem where basically in their software development environment that's kind of a mix of Linux and Windows, they basically were running on an existing NetApp platform. And they just hit a performance wall in a couple ways. First of all, their environment was so big it took 48 hours for them to do a dedupe job. So they would have to basically keep a bunch of their array empty to land data all the time, and then find a window to dedupe it and whatnot. So it was killing their space efficiency. And this particular customer just had chronic VM alignment issues. They used all the tools, they did everything the right way, but they still had just massive issues around VM alignment to the point where it was impacting their performance horribly. So they moved over to us, they got great dedupe. They found that there were just a bunch of operational benefits. So the time to provision a VM went down by 5x, the cloning time 3x, and their VM alignment issues just completely went away. All right, so VMDK type. Yeah, you want to take this one, Robbie?
Sure.
Sure. One other note on the electronics vendor was I just had a chat with them the other day, and they're doing this massive VCD deployment, and as part of that, you're cloning bunch of these VMs, for the end user to consume, and everybody logs in at the same time, and they're just bringing the storage to his niece. But in our case, they reduce the time of provisioning the VMs, and the developers are up and running in a matter of minutes. So that is one of the things we will add to the slide. So different VMDK types, do they really matter? So I set out to see what exactly the behavior if I do either zero tick or lazy zero tick or flat or just thin disk provision. So on a normal array, you all know what those three formats are, so I'm not going to go into that. So in the real deal is you run IO meter, which is like a synthetic workload. You could argue that it might not be simulating any great test bed, but 70-30 mix of read and write. So I tried that. I saw no difference. I'm like, okay, let's kick it up a notch. I started running jet stress on these three different kinds of data formats. I pretty much saw no difference.
Your jet stress results are actually in the next slide, if you want to show those.
Okay. So this is the jet stress results where I had the eager zero take, lazy zero take, and thin. There's absolutely not much of a difference, only a single decimal point. It's all 1.3 for reads, 2.0 for writes. So it's same CPU consumption, and because of VAI integration, the thick provision of like a 1 terabyte LAN happened in a jiffy. It was no time at all. So that was one point there, and a lot of people worry about if I want to do FT, I got to do a thick provision LAN or eager zero thick because it doesn't work with any other format, and they think that they're going to incur a lot of hit if you start to do a flat disk. But by default, they usually configure a flat disk and pray that there won't be a performance hit later on, right? But in our case, all those things is taken away. You don't have to worry about what format the disk has to be in. And the CPUs are almost pretty much the same. Actually, I conducted another test where let's try the same LAN on an RDM, and that also did not give me any difference. So actually, I was surprised to see 0 as one of the 0 is my favorite number, it seems like. So 0 as one of the kernel average times when I looked at the ESX stock numbers. So it's pretty interesting that you don't have to worry about RDMs and thick, thin, or flat. But of course, you're doing P2E. RDMs are great. You can directly migrate the the Exchange database or SQL database to the virtualized environment. Same thing goes with alignment. I guess Matt talked about alignment in the earlier. Our blockchains are quite well. It's very well articulated in the blog. So this is a well-known problem. We don't need to worry about alignment anymore. So Windows 2008 and Windows 7. The block size is already 1 meg, so we don't have to really worry about that. And in our case, even if it's an older version, older 2003 desktops or applications, there is not really any change there. So in order to prove it out, we ran IOmeter with different IO sizes, and pretty much the same latencies, relative latency from all these different aligned VMs.